this computer. Here we go.
Awesome.
All right, so now I can record. Everything's good. So we just talked about how none of these are the same. Back when we started exponentials, we took a look at something like y equals 2 to the x.
Uh-huh.
And if I plug in 0, 2 to the 0 is 1. If I plug in 1, I'm up at 2. So I had a graph that looks like this for this exponent.
Hmm.
Okay. When we got into logs and we swapped the x and y and so on, y equals log base 2 of x was a graph that looked like, do you remember?
Went up the middle and over to the right.
Yeah, yeah, they're actually inverses. So in that last chapter, when you talked about inverses, you had symmetry over the line y equals x.
Right.
So if I flipped it, it actually goes like this.
Okay.
Okay. So this is what logs look like, this type of shape. This is what exponents look like. And when we work with logs, we know that x has to be greater than 0 for my domain. I can't put negatives in here.
Okay.
Log base 2 of a negative number is not going to work.
Gotcha.
Or so good?
Yep.
Okay. So if I was doing log of 1/2 x, well, this was log base 2 of x. We now want log 1/2 of x. What's its graph going to look like? Well, it's going to look like this. It's still going to go through 1, but the values are going to change just like we did with in college that we did. Yeah, you got something it's going to look similar to that.
Hmm.
Okay, so that's going to be the log of dotty dotty dotty. And again, I could do this 1/2 to the y power equals x. And if I wanted to put values in, I could put values in, but that's what the graph's going to look like.
Okay.
Now, just like we did before with other parent functions, like when we had y equals x squared, and we went, oh yeah, it looks like this, and we were happy. And if
Hmm.
I did something like y equaled x squared plus 1, what did I know happened to the graph?
Went up one.
It got shifted up and down. So it's the same kind of things would happen with these graphs. They could get shifted left or right, up or down. We could do the shrink and grow, the difference between the base of 2 and the base of 1/2. So we're looking at things like that.
Okay.
Y equals log base 2 of x plus 3. That would move the graph down 3 because remember it was x minus h. We had this
Okay.
y equaled x minus h and then out here plus k. And we had squares and different things like that. But now we're working with logs instead. Our
So when
parent
it's an exponent, when the x plus three, only when that's an exponent is when it gets moved left, right?
well, the left and right is going to be the h.
Okay.
What's stuck on out here at the end, this plus k is going to be our up or down. So remember, we did squares before, y equals x minus h squared, and that was our parent function. Now we're doing logs, but the h and k still are going to work the same,
Okay.
moving me up and down. By the long pause, I'm going to say y equals log of x plus 2 plus 2. What would that look like?
I would go up two and over to the left two.
First of all, I have this, and then I have the dot, 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 dot. That's going to be my basic log function. Depending on what number is here, is it's either going to go up higher or turn faster.
Yeah.
And that's going to depend on this base. But yeah, we do the H first. So it's going to go left 2 First thing I'm going to do is go dot, 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 dot. And that's y equals log of x plus 2. And then, as you said, we're going to take the whole thing and move it up. Again, my asymptote makes it nice and clear what's going on. And I have a graph that looks like this.
Okay. So the fractions, which I just love fractions. I don't know, like I thought I knew how to calculate the exponents of a fraction, or like do the chart, the X and Y chart graph
Mm-hmm.
of the fractions, but apparently I need a refresher.
Okay. Let's start with this one. Here's y equals 2 to the x. I'm going to start with exponents. And we know it crosses at 1. The next spot would be 2. We're going to go something like this. Okay.
Yeah.
If I said y equals 6 to the x, that's still crossing at 1. But when I put in 1, I'm all the way up at 6. So this guy is growing faster.
Hmm.
So it's just a matter of how fast it's growing compared to a basic 2 to the x, a 6 to the x, a 10. What if I said y equals 1/2 to the x? Still here, but where am I at 1? Well, if I throw in 1, I'm now down here at 1/2. So that actually flipped it when I went to that fraction. So if it's greater than 1, it's going to grow. If it's less than 1, it's going to decrease. Because when I put in 1, I'm at 1/2. When I put in 2, I'm at 1/4, and so on.
Right. Yeah, I feel like some of the where I got confused, it would be a fraction, but then you would get a whole number. I don't really know.
So are you on these, the exponents?
Yeah, like okay, let me give you another example here.
Go ahead.
All right, two, um, this is an exponent with its asymptote. Two in parentheses 4/5 with the x as an exponent.
Okay.
Yeah. How do I do that?
All right. Is this going to grow exponentially or is it going to decrease exponentially?
Decrease?
Decrease. Why is it decreasing?
Because it's less than one?
Absolutely. Absolutely. Now, this 2 is doubling everything. So, I mean, you could start out with a graph and just do y equals 4/5 to the x power. And
Mm-hmm.
you could start going, well, I know when it's 0, it's 1. That's always the case.
Right.
When it's 1, it's 4/5. So out here at 1, it's coming down, and I would have this graph. And that's just for y equals 4/5 to the x. Now,
Mm-hmm.
what's the 2 do?
Um,
This says take a number and multiply it by 2.
oh, okay.
So it's going to double everything. So instead of being at 1, it doubles it up to 2. Instead of
Okay.
being at 4/5, it's going to double it up here to 8/5.
Yeah. Like that all makes perfect sense. I don't know why, because I felt like that's how I was doing it, but I kept getting them wrong. And I'm like, I don't understand. Maybe I need to go back and try them again. I just kind
They're a pain in the butt.
of, what's that?
I said they are. Well, I can't say that. I'm recording this.
Oh.
And then Thursday at noon, when you're done with your test, you're going to forget all about them.
Oh God. I just hope I can remember them for the test. I'm pretty
Well,
sure I'm screwed
you're
on this one.
proving to yourself that you can think this way.
Yeah. It's just a lot to remember in a very short period of time. So I'm just a little panicky right now. And I think that's hurting me. That's making me kind of not think straight. So hopefully I'll have till 4 o'clock today to study, and then I have till 4 o'clock tomorrow to study. So hopefully it all clicks at some point.
And what do you need, about an 80 to still get an A?
I need an 81. I think it's an 81.
81. I did just put in the last three homeworks.
Yes.
I added those in.
Yeah, I submitted the assignment too. So, oh, so the final.
Yes.
Does it, I'm guessing 20 questions are on the last unit, and then what, eight of them are on previous units?
Um, what I can do is, I know people love to ask this question, and oh, who was I? I was actually about to grade your last assignment. Saw all the words you put in.
Yeah.
Okay, so I'm going to go to your class. Your final is over on Alex, isn't it?
Yeah.
All these different learning systems. I'm all over the place.
Yeah, I like Alex. I hated it at first, but
Yep. Yep. I was just starting to read the comments. I didn't realize it was yours. If I go here, assignments, assignments, and final exam. If I take a look at it, where's the questions? Content. Here we go. Oh, it doesn't break it up by section. There are 28 questions.
yeah.
3 by 3 system equations. You're familiar with that?
Yeah, they were a nightmare, but once I got it,
Okay, good.
I started liking them.
Okay, yeah. Yep, that's going to be like the last question on the test.
Yeah, I kind of figured it was definitely going to be in there since it was kind of tricky. A lot of parts.
I don't want to remove that question. I don't like that one. Edit. Oh, there we go. Good. I'm glad you brought this up because there's a question on the test that I don't like. It used to be an assessment question. We had to have it on there, and it is gone. It's a question that would have probably driven you crazy.
I appreciate you getting rid of that.
Yes, me too. Because I feel bad when it's on there. It's about the half life of ibuprofen in the body.
Oh,
Okay. What
I
else?
might have actually got that one. It's the ones that I struggle with at first that I tend to stick. The logarithms, when I was doing the homework, I was like kind of blasting right through it. But the problem is when I go back to review, I don't remember all the little tweaks on how to solve them. So like it hasn't been
Yeah,
embedded the same way the tough ones were.
right. And there's a lot of students who will do view an example and solve the problem and never really get it. They just mimic what they saw in view an example.
Yeah, because it's like if I see it, like I'm reviewing like crazy the last couple days, and my husband's like, "Well, have you asked?" Like my daughter, she's really good at math. Have you asked her? I'm like, "It's not that I don't know how to solve them; it's that I can't remember. As soon as I see an example, it's like, oh yeah, duh, that's what I got to do." So just trying to,
And summer's fast.
yeah.
Summer session is fast.
What am I going to do with all my free time for 3 weeks? Clean my house.
Take your dog out.
Yeah, she definitely hasn't lacked walks. She's my break time.
Uh-huh. Mine has a frisbee and she's not supposed to.
Aww.
It's the outdoor toy. It's not the indoor toy.
Oh, she takes all her toys outside. It's like we have a toddler living here.
But dog doesn't move. Dog.
Nathan,
Hi, buddy.
baby girl.
Oh, never mind.
She never comes when you tell her to come.
Oh,
She just rolls over, makes you work for it. Here she comes.
all right.
Sweet girl. She's my little class buddy.
All right. Got any more?
Nope, I think that's it. Oh,